Good evening, ma'am.
So today we'll discuss the solution of system of linear differential equations. Okay, and then means when we are talking about differential equations means homogeneous type and non-homogeneous type both will consider. So first let's start the basics of that. So I'll simply write the linear system of differential equation of order 1. So we'll discuss the system of order 1 only. So let's write. Let's start. Topic is linear system of first order differential equations. Okay. This is your topic. Now let's write the general system. Suppose you have an independent and dependent variable x1, x2 up to xn, and these dependent variable depends on a single independent variable t. So let's write for that dx1 dx1 over dt is equals to a11 x1 plus a12 x2 up to a1n xn and some function of independent variable t. So when we are talking about system means we have more than one differential equation. Now more than one means let us write the n differential equations. So x2 is equals to a21 x1 plus a22 x2 a2n xn and some another function of independent variable t. Let's write the nth equation for xn dt. So a12 and 1 x1 a and 2 x2 a and n xn, and let us say this. So for each system of first order differential equation you can always write the corresponding matrix form. So if I simply write here x1 dash, where dash means the derivative with respect to t, x2 dash xn dash, right? Then a11 a12 a1n a21 a22 a2n an1 an2 ann. The coefficient matrix, coefficient of x1 x2 xn, right? Then f1t f2t fnt. So if you simply multiply this matrix, this is of n cross n matrix and this is n cross 1 matrix, right? So when you simply multiply this and then adding this and then you write the component like x1 dash is equals to first component of the matrix, because when you solve this RHS you will get simply one n cross 1 matrix. So here you will get nothing but this. So when you compare the components of both the matrix, this and this, you will get the same differential equations. Okay, so for each system of first order differential equation, you can always write a matrix form. Simply I can write this as x dash is equals to ax plus f. Okay, and if contains f means ax plus f. So this is the non-homogeneous part. And when you are writing this means simply write where x is a column vector x1, x2, xn. So its derivative means d by dt of x1, x2 up to xn. And simply write A is this and cross n matrix like this one, and F is that column matrix containing F1t, F2t, Fnt. So this is the corresponding matrix form of this system of differential equations. Okay, so if it is containing this means this is the non-homogeneous system of first order differential equation. And suppose this f is 0 means it is not containing the function of independent variable t. That means this is the homogeneous system of differential equations. So let's discuss. If the system is homogeneous, that means you will simply have x dash is equals to ax. Okay, this. For example, suppose we have this dx by dt. First equation is 3x plus 4y. Another equation is given as dy by dt is equals to 4x plus 3y. Okay, now if independent variable is t, please see it carefully. X and y both are dependent variable depending on single independent variable t. So if this equation containing the function of t, then it will be non-homogeneous because it is not containing, that means homogeneous. So I can write this as x dash y dash, right? This as 3 4 4 3 and xy. Okay, when you multiply this means you will simply get 3x plus 4y, 4x plus 3y, which is equals to x dash y dash. So when you compare these first component of this matrix with this, means if two matrices are equal means their corresponding position element should be equal. Like this element would be equal to this, so you will get first equation. This element will be equal to this, so second equation. So this is the corresponding matrix form of this system of first order differential equation. That means you can write x dash is equals to ax, where x is equals to the column matrix xy, a is equals to the coefficient matrix 3 4 4 3. Right, now let us see another example when you have the non-homogeneous system of differential equation. Six x plus y plus z plus now t. 3x plus 4y plus z, let us take 10t. dz over dt is equals to 4y plus 3z, like that. Okay, so the corresponding matrix form will be x dash is equals to ax plus f, or instead of writing directly this, let us write first x dash, y dash, z dash. These are the dependent variable. Okay, then coefficient matrix 6 1 1 3 4 1 X coefficient is 0, so 0, 4, 3. Now what some students are doing, they are adding this t, tan t and this in here. But here it is the coefficient matrix of x, y, z, dependent variables, this. So you cannot add the non-homogeneous part. Then you can write t, tan t, 0. That means this is x dash is equals to ax plus f form, where x is the column matrix, this x, y, z, a is the coefficient matrix, and f is the column matrix of functions. Okay, so this is the system of differential equations. Now up to here means system of differential equation, but how to solve? Suppose if you have this system of differential equation, now how to solve? That means from this, what would be the value of x and y? X and y. Solving means you should have the value of dependent variable in terms of independent variable, right? So let's discuss the solution. First we'll discuss the solution of homogeneous system of differential equations, then we'll go to the non-homogeneous one. So here again the eigenvalues, eigenvectors, because now it is matrices, right? So let's start. Now linearly dependence and independence already we discussed when we were discussing the eigenvalues and eigenvector problem. Okay, one more time I'll discuss because it is necessary here. Linear dependence and independence of vectors. And independence means the eigenvectors we are going to calculate should be linearly independent. Okay, so let x1, x2 up to xn be the solution vectors, be the set of solution vector. Homogeneous system. Okay, so the set, so this set of vectors will be Li. Li means linearly independent if there exist scalars C1, C2 up to Cn such that if we'll take the linear combination of these vectors, how to take linear combination? x1 with c1, c2 with x2, cn with xn. And if this linear combination is 0, right, such that this all ci's are 0, means when you are taking the linear combination of this and when you are calculating, all ci's should be 0, means c1 is 0, that is c1 is equals to c2 up to cn, all are 0. That means linearly independent. Okay, and if any of ci is not equal to 0, that means linearly dependent. Okay, so if you want, I can give an example. Suppose we have, let us take two vectors. x1 is 2, 3, x2 is 1, let's take 1, 0. Now you need to check whether these x1 and x2 are linearly independent, Li or Ld. Okay, linearly independent or linearly dependent. So what we take, we'll take, because x1, x2 two vectors, so take linear combination, c1 with x1, c2 with x2. Take linear combination as 0. So c1, now 2, 3, that means when we are writing this, means you can write in this form, c2 and 1. Please mute yourself. Is equals to 0. Right? Now multiply this inside. So this is the column vector. So when we are writing in this form, that means you need to take comma, like ordered pair. Okay? That means transpose of this. So this is 2c1 and 3c1. We can multiply in a bracket, right? With comma, c2 and 0. That means here also 0, 0 form, right? So if it is, this is the matrix form, this should be the matrix. That means now how to add two bracket? First component. That means 2c1 plus c2, comma 3c1 plus 0. So this is equals to, now consider this is 0, 0. That means 2c1 plus c2 is equals to 0 and 3c1 is equals to 0. So from here c1 is equals to 0. Now c1 is equals to 0, that means c2 is equals to 0. So c1 and c2 both are 0. So linearly independent when all the ci's are 0. That means this is linearly independent. x1 and x2 both are linearly independent. So you can check with this. Take the linear combination and try to get all these scalars as 0. If any of the scalar is non-zero, that means linearly dependent. So let's come to the solution. Solution of first order system of first order differential equation or even homogeneous, GNEOUS. Okay, so this is first order differential equation, homogeneous one. Like suppose you have x dash is equals to ax form, then the solution will be x, means we need value of x, right? If this is the differential equation, we need the value of x, will be c1 k1 e power lambda 1t, c2 k2 e power lambda 2t, cn kn e power lambda n t, where lambda 1, lambda 2 to lambda n are the eigenvalues. So you know how to find the eigenvalues, right? Of the matrix A, and k1, k2, kn are the corresponding eigenvectors. Okay. For example, a simple example I'll take. Solve the following system of differential equation. Dx by dt is equals to 2x plus 3y. dy by dt is equals to 2x plus y. Okay, so first thing is you need to write the corresponding matrix form. X dash y dash is equals to value of A 2 3 2 1 and xy, right? Now this is will be the solution. So if it is n system of equations, you will get up to n. So second order means 2 cross 2 matrix, so you will get 2 eigenvalues. So up to here you will get answer. Now matrix A is this 2 3 2 1. How to find eigenvalues? Determinant of A minus lambda I is equals to 0, right? That means 2 minus lambda 3, sorry, determinant 2 1 minus lambda. So when you solve it, you will get lambda is equals to minus 1 and 4. So for lambda is equals to 1 minus 1 eigenvector. Now eigenvector we are denoting by k1, okay, and this will take as x1, the solution c1 x1 plus c2 x2, write that, okay. So k1 we are denoting by the eigenvectors, we are denoting by the k1 k2 and kn. So for lambda 1 k1, you know how to find eigenvectors, so I'm not going to solve it here, you need to find. And for lambda is equals to 4, another eigenvector is 3 2. So once you have eigenvalues, eigenvectors, then solution capital X is C1, K1 means 1 minus 1, e power minus t, C2, K2, e power minus, e power 40. Now we know that we need to find the value of X and Y, right? So you can proceed further. X means you can write in this form xy, this is xy, right? Now see c1 e power minus t, right? Minus c1 e power minus t, this is your first, just multiply inside. 3c2 e power 40, 2c2 e power 40, this is your second. Now because the order is same, this is 2 cross 1, this is 2 cross 1, that means you can add these matrices, right? That means c1 e power minus t plus 3c2 e power 40 minus c1 e power minus t plus 2c2 e power 40. So this is equals to xy. Now comparing this, x is equals to this and y is equals to this. Solution, right? So I'll write solution here. X is equals to c1 e power minus t plus 3c2 e power 40. Y is equals to minus c1 e power minus t 2c2 e power 40. So these are the values of x and y. This is very simple. So one question I'm giving you for the practice that you need to solve. Dx by dt. If it is, first see the independent variable is t. If it is not containing any function of independent variable, then it will be homogeneous. Students are getting confused, like what is homogeneous and non-homogeneous in this. Even I am explaining in the very simple method. Now you need to solve this. Any doubt? So this was the first case when the eigenvalues were distinct. But what if the eigenvalues are repeated? Because if the, like what we did in second module, If the eigenvalues are repeated, to make them linearly independent, we are just simply multiplying by the independent variable t. But here, because this is the matrix form, this is the system of differential equation, so we cannot directly multiply by t. So this will suppose that now, like lambda 1 is an eigenvalue of multiplicity 2. Suppose that eigenvalue is repeated twice. And that there is only one eigenvector. See, suppose you are getting first cases when I'll simply write here when eigenvalues are repeated. Eigenvalues are repeated, so means for even the repeated eigenvalues you are getting the eigenvectors, distinct eigenvectors, and if the distinct eigenvectors, the solution x is equals to c1 x1 plus c2 x2 all will be linearly independent, because x1 and x2 for the repeated eigenvalues you are getting linearly independent. But what if multiplicity of eigenvalue is 2 and you are getting only one eigenvector? Then how to find this x2? Okay, so in a detail we'll discuss in next class because it will take time. Any doubts?
No, ma'am.
Okay then. Please complete that question. So I'm taking attendance. Please mark your attendance, everybody. And those who have marked their attendance may leave.
Ma'am. Ma'am.
Yes.
Ma'am, I have a doubt, ma'am, that homogeneous equation means independent variable should not occur under RHS.
What?
Homogeneous equation.
Homogeneous
That
equation.
means independent variable should not occur on the RHS.
On RHS, yes. Okay.
Not clear, ma'am.